So let me ask you this question before we get into this. What is, oh, I don't know, 5x plus 3x? 8x, right? You just add the coefficients together. As long as my variables are the same and they're both raised to the same power, I just do the operation on the coefficients and I leave the x by itself, right? So even if I had something like 4x squared minus x squared, what does that get me? 3x squared, right? There's really a coefficient of 1 there, so I just do 4 minus 3 gets me, 4 minus 1 gets me 3x squared, right? This is nothing new. If my variables match, if I have like terms, I can just do the operations on the coefficients. Radicals work the exact same way. It's just that you have to have like radicals, okay? So, big star to start off with, you can only add or subtract like radicals. Just like you can only add or subtract like terms. It's the same exact concept. And I do it the exact same way. So just like I had 5x plus 3x, say I had 5 root 2 plus 3 root 2. Well, what do you think that gets me? 8 root 2, just like it did up here, right? It's just that they're radicals. So it's just saying I have 5 of these root 2's and I have 3 more of these root 2's. So altogether I have 8 of these things called root 2's. That's it. So you just do the operation with the coefficients and you leave the radicals alone. It just stays the same. So if I did something like 10 square root of 7 minus, 6 squared root of 7, that's going to get me 4 square roots of 7. As long as I have like radicals, that's all I got to worry about. So what happens when you don't have like radicals? Well, what happens if I ask you to add these together? 2x plus 3y. What do you get? What's 2x plus 3y? You can't. That is your answer, right? They're not like terms, so you can't add them together. So the same exact thing would happen if I had something like 5 root 3 plus 7 root, 6. They're not like radicals, so I can't do it. Like, that is my answer. That is them added together. Does that make sense? Okay, so let's try this. Well, let's just add. These are already simplified. Nothing else I can do there, because they're not like terms or like radicals. Okay, so let's just try something like this. What do you think the square root of 3 plus 2 square root of 5 minus 6 square root of 3? What do you think that would get me? Jess? Exactly. These two are like radicals. So I can combine these two. And then that one doesn't have another root 5 to combine with, so it's just going to stay. So if I put these two together, remember there's really a 1 right there, so I have 1 root 3 and a negative 6 root 3. So together they're going to get me a negative 5 root 3, and then I just have this plus 2 root 5 on the end. Is it wrong if you have the 2 root 5 first and then a minus 5 root 3? No, it's the same thing. And we get a little particular with variables, like you have to go alphabetically. There's no alphabet here, so you don't have to worry about putting them in any kind of order. So if there's no variables involved, it really doesn't matter. The only thing I would say, if one number doesn't have a radical attached to it, so like for example, let's say your answer was, well, I'll make one like that. Let's try this. Let's do 5 square root of 7 minus square root of 7 plus square root of 4. Okay. Do I have any like radicals here?
Yes.
Yes, I do. The square root of 7s, right? So what is 5 square root of 7 minus square root of 7? 4 square root of 7. It is such a common mistake to say that the answer is just 5. It's not. 5 of these minus 1 of these would leave me with 4 of these. Now, this, what is the square root of 4?
2.
It's just 2. Okay, so this isn't wrong, but if one of your terms has a radical in it, you usually want to put that at the end. So I would just rewrite it as 2 plus 4 root 7. Again, I'm not going to mark you wrong, but it's just a good habit to get into, always putting your radical at the end. Okay, let's try one more. How about 3 square root of 8 plus 5 square root of 2. Anybody got it?
Would it be 8 root 8? Would it be 8 root 16?
Alexandra?
Close.
11 root 2.
Yes. How? How could she get 11 root 2? Aren't these not like radicals? I have an 8 and a 2. They're not the same. How did you add them together? Tell me.
I simplified root 8.
Exactly. This guy can be simplified. So at first glance, it doesn't look like they are like radicals. However, doesn't the square root of 8 have a perfect square factor over there? Right? Look at your perfect squares. Can't I divide 8 by 4? So that answer, or that term, has to get simplified first. So I'm just going to bring down that 3. 8 splits into the square root of 4 times the square root of 2. So isn't that really 3 times 2 times the square root of 2? Right? Because the square root of 4 is just 2. So I really have 3 root 8 is the same thing as 6 root 2. And now you can see, oh, I can add 6 root 2 and 5 root 2. Yeah, I can do that. That would get me the 11 root 2. That's where that comes from. Okay, so you have to look and see if anything needs to be simplified. And if it does, I would go ahead and simplify it. And then you might end up with like radicals that you can add together. How do you think we handle cube roots? What if I asked you to do something like 7 times the cube root of 10 plus 4 times the cube root of, I don't know, 3 minus 6 cube root of 10. So none of these can be simplified. I do have some like radicals though. The root 10s, cube roots of 10. So that means I can put these two together. And what would that get me if I put them together? 1 cube root of 10. So I don't even need to write the 1. You can if you feel like it. And then I just bring down the plus 4 cube root of 3. So cube roots don't work any differently. It's the exact same thing. Same, it could be any root, 4th roots, 5th roots, doesn't matter. Oh, here's a good question. What about this? What if I had 7 square root of 3 plus 4 cube root of 3? Ooh. What do you think I do with this? Are they like radicals?
Yes.
Because he's a cube root and he's a square root. It's like having x and x squared. They're both x's, but they're raised to different exponents. It's the same thing. If they are being, if I'm taking different roots of them, they're not the same. So literally, that's as far as I could go. That's my best answer. This doesn't happen very often. I mean, it can happen, but usually the problems that we give you, it's either all square roots or all cube roots. But it could. Let's see. Do I have to show you anything else today? We're actually ahead of where we needed to be. Yeah, let's just try one of these, and then we can be done. Here's a helpful hint. If you look at one like this. 2 square root of 20 minus square root of 20 plus 3 root 20 minus 2 root 45. Okay, so there's a smarter and a harder way to do this one. I notice right now I have a whole bunch of square roots of 20s. Now, the square root of 20 can be simplified. That's true. But I would not want to simplify each one of these 3 and then combine them. You can combine them first and then just simplify your answer. That'd be so much easier doing it 1 time than doing it 3 times. So let's leave it as square root of 20 and put these 3 together. What would you get if you did 2 minus 1 plus 3? 4 square root of 20. So I have 4 square root of 20 and then minus the 2 root 45. Now I would just simplify those 2. You can't leave your answer like this because these need to be simplified, right? So your answers always have to be in fully simplified radical form. So I look at this and I say, okay, what goes into 20? 4. So that would be 4, and then break this up into 4 times 5. So that'd be 4 times 2 root 5, or 8 root 5. And then this one, let's see, 45 can break up into 9 and 5. So that'd be 3 root 5. Don't forget about this minus 2 here. So that'd be a minus, oh my gosh, what do you know? So my final answer is actually, someone said it, I think, or 2 root 5. Wow, that didn't look anything alike at first, but after you simplify everything, there you have it. Does that make sense? Everybody's all right? Okay. Oh, this is great news. So now, I'm just looking at our schedule here. Well, let's stop this video because we're done with that.